All right. Good afternoon again. Good afternoon, everyone. And it's good to be back live. So medyo matagal-tagal tayo since huling sama-sama ng live. Pero it's good to be back. But before we continue with our discussions, I have one of my major students, Chazelle, who would like to invite you with one of their events. Go ahead, Chazelle.
Thank you po, sir. Good afternoon, everyone. I am Chazerlinis Casanova, and on behalf of AMAT 199 Section T, under the supervision of Associate Professor Aleli Domingo, I would like to invite all of you to our upcoming webinar event with the theme Past, Present, and Future, the Old Script Meets the New Technology. This webinar will happen on Monday, 15th of November 2021, 9 o'clock a.m. via Zoom and Facebook Live. Our guest speaker, Mr. Rodney Pino from the University of Philippines Silliman and Baguio, will discuss their study entitled Optical Character Recognition System for Bayesian Scripts using Support Vector Machine. If you're interested, you can pre-register using the link you can find on our Facebook page. Certificates of participation will be distributed to the participants if they answer the evaluation form. Also, Sir Neil will be giving incentives if you attend the webinar and also pass the necessary requirements you will require. For more updates, you can check our official Facebook page, AMAT199-seminars. If you have other concerns, you can also send us a message on our Facebook page or send us an email at amat199.externals@gmail.com or amat199.records@gmail.com. Thank you so much, and together let us unveil the relationship of the past, present, and future. Thank you po, sir.
All right, you're welcome, Chazelle. So if you guys are interested and you don't have anything important to do on Monday morning, so I encourage you to attend the webinar. You might get some bits of information there and probably a roadmap sa kung anong pwede niyong gawin pag magme-major na kayo come 1 or 2 years from now. All right. So what I'll just require from you to get some little incentives for attending the seminar would be to submit a short or what however long you want reaction paper. So kahit isang paragraph, two paragraphs, or 1 or 2 pages, that's fine. So that sulat nyo lang kung ano yung nakuha nyo or what's your honest reactions about the seminar, kung ano yung natutunan nyo, or kung ano yung napulot nyo mula dun sa seminar na ano nagustuhan nyo, and so on. So yeah, wala namang specific format. I'll just open up a submission bin in Canvas for you to submit the reaction paper to that event. Okay? So with that, let's do some housekeeping first, some announcements. Reminder lang, yung worksheet number 6. I double check ko sa Canvas. I do kailan nga sa Monday, November 15th, right before midnight. So your lab instructors will be more than happy to help you on Monday if you still have some questions about worksheet 6 about the principle of mathematical induction. And then worksheet 7 is all about axiomatic systems and I think a little bit of naive set theory. So hopefully ngayon matouch natin yung naive set theory and completely finish this lecture, this study guide on Wednesday. So yung deadline ng worksheet 7 would be on Friday right before midnight as well. So that is the 19th of November right before midnight. And then let's see when we can schedule the submission of worksheet number 8. So I also look at the course guide. Mukhang medyo delayed tayo ng isa't kalahating linggo, but that's actually shorter than what I expected. I thought we are 2 weeks or 2.5 weeks behind. Pero we are still on a good track pa rin pala. So yeah, we're still in a good shape. Siguro kung medyo mahuhuli tayo sa dulo ng semestre, siguro I will just tap your lab instructors to augment my discussions. Baka malimitahan na yung examples na i-discuss ko sa lecture, lalo na pag nagpunta tayo sa algebra of sets, which would be 1 week or 2 weeks from now. Yung more examples sa lecture nyo na lang sila gagawin para makapaghabol tayo ng konti. But rest assured, I would not sacrifice the substance of our discussions just for the sake of finishing the course guide, okay? Because napaka-importante nga ng Math 101. This is your foundation for your future math careers, okay? Now, last time, I hope you were able to look at the video that I recorded during section ano ang section nila? Section T's class meeting about axiomatic system and how we develop mathematics as an axiomatic system. Hindi lang basta nagde-define ng terms, nagpo-prove ng theorems sa math, dapat solid yung foundation ng mathematical system. And you can think of the foundation of any mathematical system or mathematical branch to be a set of undefined terms. Sila yung mga primitive objects na kailangan natin para maumpisahan yung ating discussion. All right, so we have certain types of objects to talk about. And then aside from these undefined terms, we introduce some basic notions. So mga basic notions that are assumed to be true, they don't need any proof because they will serve as the foundation of the logical system that we are developing, because math is a logical body of knowledge. So itong mga axioms na to, or itong mga ideas na to, ang tinatawag natin na axioms. Sila yung mga governing rules, the basic governing rules in our discussion. So sila yung lagi natin babalikan, at lahat ng mga theorems na i-derive natin dapat manggaling doon sa set of axioms na yon. All right? So if you're more into politics, pwede mong tingnan yung axioms to be the constitution of a country. All right? So siya yung pinaka-basic. These are things that are held to be in a high tower. So sila yung hindi pwedeng ma-violate. So katulad ng sa policy, yung constitution, pag nagpasa ang Kongreso ng kahit anong batas which is contrary or contradictory to what the Constitution mandates, na-invalidate yung law passed by Congress. So ganun din sa axioms. Lahat dapat ng theorems ay hindi nagko-contradict sa axioms. All right? And that leads us to nice and desirable characteristics of an axiomatic system, which is basically ano yung properties na gusto nating ma-possess ng ating mga axioms. Una, dapat yung sistema natin ay finitely describable. Dapat as much as possible, kakaunti lamang yung axioms na gagamitin natin. All right? Second, we want the axioms to be consistent, and thus it will bring forth a body of knowledge that doesn't have any internal contradictions. Yun yung tinatawag natin consistency. Dapat walang axioms na nagko-contradict sa isa't isa, or dapat yung mga axioms wala silang ipanganak na theorems that will be contradictory to other axioms or to other theorems. Third is completeness of the axiomatic system. Ibig sabihin ng completeness, dapat kaya nating ma-prove lahat ng statements about the objects of study. All right? So dapat posible na pag meron kang isang statement about the terms that you defined in your axiomatic system, you should be able to provide a proof that that statement is either true or that statement is false. All right? And then, ilan na ba yun? Finitely describable, consistent, complete. And then the fourth one is the independence of the axioms from each other. So dapat walang axiom ang kaya mong i-prove using other axioms. Right? So kasi kung yung isang axiom ay provable naman pala by one or more of the other axioms, then you can just demote that axiom to just be a theorem. All right? So yun yung apat na desirable properties. And mathematicians always thought na, okay, posible pala akong makapag-design ng isang body of knowledge that might be able to unify everything, okay, into one axiomatic system possessing those four properties. And for centuries, mathematicians sought that unifying theory of everything. Kaya lang, binasag ni Hilbert, hindi pala ni Hilbert, binasag ni Kurt Gödel yung pangarap ng mga mathematicians like Hilbert, like George Boole, etc., na makakreate ng isang axiomatic system that consists of those four properties. Sa na-prove ni Gödel na kapag ka meron kang isang consistent axiomatic system, hindi siya pwedeng maging complete. Meaning, in a consistent axiomatic system, there are statements that are not provable. So hindi natin siya kayang i-prove or disprove, and we just need to live by that fact. And then second part ng incompleteness theorem ni Gödel, na hindi natin kayang i-prove na ang system ay consistent kung siya ay consistent man talaga. All right? So there is no proof of consistency of an axiomatic system, even if it is indeed consistent. So we just need to just observe if indeed there are no internal contradictions in the axiomatic system. So doon umikot yung discussion last time. Medyo popular lecture siya. Kasi mas maganda sana pinanood ko na lang kayo ng mga TED Talks about axiomatic systems, because I cannot deliver a better explanation to that. But I hope you get some bits and pieces of ideas. Ito rin yung foundation kung bakit pag pumasok kayo sa isang major course ng math, lagi tayo nagsisimula sa mga basic terms. Hindi tayo, wala kaming ina-assume na dapat alam nyo na sa pagsisimula ng lesson. That's why we almost always starts from scratch, or always starts from almost scratch. So dinidefine natin lahat, bawat isang term na gagawin. Nililay down natin yung lahat ng rules of the game, which we call axioms. Tapos saka natin pinuprove yung mga theorems o mga observations na pwede nating makuha about these objects gamit lamang yung mga axioms, mga undefined terms, mga definitions, o mga theorems na na-prove na sa klase or na-prove na sa discussion. Kaya siguro when you look at your problem sets and unfortunately, you use one result that to your mind is obvious pero hindi ko naman pinrove sa klase o hindi ko sinabi na pwede nung i-assume, then siguro na minusan ko kayo kasi hahanapan ko kayo ng proof para dun sa statement na hindi naman natin na-introduce sa klase. Kasi may nag-govern na meta-axiom of ignorance. Ibig sabihin, wala kayong ibang alam sa isang mathematical discourse aside from the undefined terms, the axioms, the defined terms, and all of the theorems that were previously proved. All right? So yun yung summary ng discussion last time. So do you guys have any questions or clarifications about that video that you watched? Wala naman. Medyo tampo lang kayo kasi twice ko na kayong na-absent at pinanood lamang ng recording. Pero don't worry, yung incentive kanina ng AMAT 199 class, sa inyo ko lang in-announce kasi hindi pwede si Chazal dun sa other section. So, yeah. So kayo lang yung may bonus doon. Yun na lang siguro yung pangbalanse ko sa walang pa-recitation for the last two meetings. So everybody here in the class has have the opportunity to get the incentive for the webinar. Okay? So any questions about the last session? Going once, going twice, going thrice. And so if there are none, then let's continue and move on to set theory. Okay? So in summary, set theory is simply the study of sets. At ano nga ba yung sets? Siguro napakinggan nyo na to sa AMAT 19 or Math 20. At kahit na hindi nyo, doon nyo siguro unang finormalize or merong semi-formal introduction, pero before then you had been working with sets, kahit sa Math 36, Math 37, or even in your senior high school classes. Can you guys remind me, ano yung notion nyo ng set? Pag sinabi yung salitang set, ano yung pumapasok sa isip nyo? Kailan kong bumawi sa inyo ng recitation eh. So, anyone? Oh yes, Frizzell.
Ano po, collection of objects.
Okay, thank you, Crizel. Yeah, basically a set is just a collection of objects, and these objects might be imaginary, they might be abstract, they might be tangible, all right? Basta sila dapat ay mga objects of discussion, and one criteria of membership to a set, dapat well-defined yung collection. Ibig sabihin, pag binigyan ko kayo ng isang object, alam nyo from the get-go whether that element belongs to the set or not. So medyo lagyan lang natin ng qualifier. Collection siya ng well-defined or isa siyang well-defined collection of objects. Alright? So basically, kahit ano palang mga bagay can constitute a set. Kaya sa math, kailangan nating magkaroon ng idea ng set kasi yung mga objects kailangan nating ilagay into some collection and that collection will be regarded as a single entity. Alright? So pag naglagay ka ng isang element dun sa set, yung set na yon will comprise of all of its members. Hindi na natin titingnan yung members isa-isa, pero titingnan na natin sila as a definite unbreakable whole. Alright? So, ganun yung idea. And the study of sets started in the 1870s when the German mathematician George Cantor was trying to study trigonometric series and the series of real numbers. At nung kino-compare niya yung magnitude ng collection o series ng mga real numbers, nakita niya, na-observe niya na magkasing dami yung dalawang series of real numbers kapag kaya ko silang i-match to each other, or there is a one-to-one correspondence, though technical term yung one-to-one correspondence, will define it later, pero kapag kaya kong i-partner yung isang element dun sa kabilang element. So obviously, you can do that for finite sets. Magkasing dami ang dalawang finite sets kapag pwede mong pag-partner-partnerin yung mga elements nila, walang labis, walang kulang. At ganun din yung inimbento niyang notion para sa infinite sets. But that prompted George Cantor to formalize set theory. Kasi kailangan niyang pag-aralan yung cardinality or naging interested siya sa pag-aaral ng cardinality, especially of very large sets that might contain infinitely many elements. Okay? And then of course, by this time, we already have the concept of axiomatic systems. Kaya tinry ni George Cantor na i-organize yung study niya of sets into a nice axiomatic system consisting of first the undefined terms. Ang una niyang undefined term ay actually si set. Sinabi niya lang na set is a collection into a whole of definite, distinguishable objects of our intuition or thought. Ibig sabihin, kahit anong objects, ilagay natin siya sa isang collection, and that collection will be thought of as a definite whole. Ibig sabihin, that will constitute a set. Alright? Hindi lang natin kayang i-define properly yung set kasi ang magagamit lang natin para sa definition ni set ay collection or any synonym ng collection. So, sabihin mo, set is a collection, set is an aggregation, set is a compilation. Ano pa bang posibleng synonym ng collection? It is a what? Basta, maraming synonyms yung collection. Pero ang idea is, babalik at babalik ka pa rin sa notion ng set. So parang ginagamit nating pang-define kay set yung isang salita na kasing meaning niya lang talaga. Because an ideal mathematical definition has two parts. It should have a genus and a differentia. Meron siyang genus, which is a characteristic it shares with similar objects. Pero after the genus, dapat meron siyang differentia. The differentia is the property that differentiates or distinguishes the object to be defined from other members of its genus. Kaya lang pag ginawa natin yung sets, pag tinignan natin yung intuitive notion ng set, wala siyang differentia. Parang genus lang siya, collection, tapos gumagamit ka lang ng synonyms repetitively, and so on. Okay? And then another thing why this doesn't constitute a nice definition or a mathematical definition, kasi this relies on the concept of objects, right? Pero ano ba yung objects? Yung objects wala ring definition. Kasi nga, sinabi lang natin, the objects are called elements or members of the set. Pero ano ba paano mo i-define ang elements based on this idea? Ang elements ay pwede mong i-try. Sige, try ko na i-define ang elements to be members of a set. Pero anong definition ng set? Set is a collection of elements. Pero anong definition ng elements? It is what comprise a set. Okay, and so on. So it's a circular type of definition if we will allow or accept that as a formal definition. That's why it's fair enough to just don't think about it too much. Don't fret over this little tiny detail. Meron naman tayong provision for undefined terms. Pero even though these are undefined terms, it is very clear in our intuition what a set and what an element is, right? Now, conventionally, we use capital letters to denote sets, all right? Usual lang naman to, hindi to isang hard and fast rule. Pwede natin yung baliin, or kung gusto mo talagang capital letter o small letters yung gamitin sa sets, that's fine. Medyo cringy nga lang for mathematicians. Pero usually capital letters ang ginagamit para sa sets. Tapos lowercase naman para sa elements ng set. Okay? But again, these are just conventions. Gabay lang natin sila. Meron tayong free will, gamitin natin ito. So, nabutan niyo pa ba yun o hindi na? Wag na lang, mag-age reveal kasi ako. So, wag na lang. So, ito yung convention. And sometimes, we also use subscripts to distinguish as elements of the set. So, si set A, which is a capital letter, it is the set containing the elements x1, x2, until xn, separated by commas and enclosed with curly braces. So, sa sets, required tayo na gumamit ng curly braces. So, bawal yung parentheses, bawal yung angular brackets. So, curly braces yung gagamitin natin para i-enclose yung elements ng set. Alright? But just remember na ang requirement lang sa sets, may laman siyang objects, well-defined objects. So, ang set, o ang isang set, pwedeng maglaman din siya ng iba pang sets. Okay? So, this set, say, let's call this capital B, alright? This is the set containing the sets A1, A2, and A3. So isa pa rin siyang collection, alright? Kaya lang ang laman ng collection na yon ay mga collections pa rin. At ilan ang laman ni B? Sige nga, ilan ang elements ni B? Anyone? Mabagal bang internet ko ngayon, guys? Kasi dati paunahan kayo magtaas ng kamay, ano? Ilan yung elements ni capital B? Oh yes, Jasmine?
3 po, sir.
Right. Thank you, Jasmine. That's correct. Tatlo lang yung laman niya. Kahit na sets yung laman niya, posibleng si A1 maraming laman, si A2 maraming laman, si A3 maraming laman. Pero ang sabi natin ay, once you enclose them inside a set, those elements will be regarded as a single entity. So ano ba yung laman ni B? Ang laman ni B ay si set A1, which is counted as a single entity, si set A2 counted as a single entity, at si A3 counted as a single entity. So si set B, tatlo lang yung laman niya. Ang laman niya ay si set A1, si set A2, at saka si set A3, regardless of how many elements each of these three sets contain. All right? So ganun yung idea rito. And there's another thing here. The same members of a set must only be written once. So kung si A1, nasulat mo na siya, hindi mo na pwedeng gawing A1 pa uli yung pangalawang element. Kasi bawat isang element ng set dapat once lang siya sinusulat into this notation which we call the roster method. Okay? So ang roster method ay isa lang paraan ng pagsusulat o pag-characterize ng isang set by enumerating all of its elements or providing for a pattern of the first few elements that is assumed to be carried over until the last element in the list. So isa lang siyang listahan ng set. Okay, so here are examples of sets, set of the past presidents of the Republic of the Philippines, set of condiments, the set of the first 10 prime numbers, the set of even prime numbers, and the set of points on a unit circle. All right? So, alin sa kanila ang meron lamang finite number of terms? Though hindi ko pa na-define kung ano yung ibig sabihin ng finite, pero for now, you can think of it as kaya nating isulat lahat ng elements nila terminally. Okay, so, or kaya nating bilangin lahat ng elements nila terminally. So, alin-alin sa kanila ang finite? Jasmine, let me wait for others. Tingnan natin. At the count of 3, pag wala pa nagtaas ng kamay, si Jasmine ulit. Oh, there we go. Neil Christian.
Sir, yung ano po sir, yung Una po, sir. Tapos, yung letter C po, sir.
Aha.
Tapos,
Meron pa ba?
wala na.
Medyo questionable. Okay, thank you. Medyo questionable pala yung set of condiments, no? So, finite bang set of condiments? Leia, you want to say something? Or napindot lang?
Ay, sir, naisip ko po kasi finite din po yung letter D.
Aha, yung letter B. At inisip ko rin finite din siya. Ano bang example ng condiments?
Letter D po. Letter D.
Letter D. Oh, yeah, thank you. The set of even prime numbers. Kasi nag-iisa nga lang pala yung even na prime number, right? Thank you, Bea. That's correct. Yung condiments, finite din ba yun? Feeling ko finite din siya. Baka marami nga lang siya pero kailangan nating tingnan sa dictionary kung ano ang definition ng condiment. But I'm sure we can determine na meron lang finite number of condiments like ketchups, fish sauce, ano pa ba? And those other sauces na ginagamit sa pagluluto. Pero eto, so pero definitely we can say that halimbawa, coffee is not a condiment. Tama ba? Or sige, I don't want to speculate, pero yun dapat yung requirement. Pag binigyan ka ng object, dapat alam mo kung nasa set siya or wala. But I suspect letter B is also finite. But we need to double check that depende kung paano dinefine yung condiments. But there's a big chance na finite siya. Depende na nga lamang kung bibilangin natin yung mga magkakasing lasa o yung same variation ng condiments to belong to the same thing. But tomato ketchup and banana ketchup, kakount ba natin sila as two different condiments or not? Or generic term na ketchup lang yung gagamitin natin para sa kanila. So those are some things that you need to clarify whenever you are naming a set, okay? But now, sige, recitation pa more. Give other elements of or 3 other examples of sets and probably give, pwede nyo siyang i-describe verbally and then give some examples of its members. Okay. Tingnan natin. Yes, Prince. Okay, I guess Prince will be typing it up. Habang nagta-type si Prince, anyone else? Perlene.
The set of students who are currently inside this meeting room, sir. Tapos po ang mga members po ay si Prince, si Bea, si Crizel, si Jasmine, si Kit, si Lauren, si Neil.
Okay, thank you, Perlene. Pero parang nagano ka lang, no? Nag-segue ka lang ng shoutouts. Pero thank you, Perlene. That's right. So if I give you a name of a student, malalaman natin kung element siya ng set. Baka sabihin ko si Luffy. Si Luffy ay wala sa room na ito, so hindi siya member nung set na binigay ni Perlene. So ganun yung characteristic. Paano natin ma-check kung yung collection ba natin ay isang set talaga. Alright? And then Prince said in the chat that the set of all noble gases in the periodic table of elements. Wow, napaka-highfalutin ng example. So, and then he said that those elements or that set will be comprised of argon, helium, neon, krypton, xenon, and radon. Prince, sila lang ba talaga yung noble gases? Mukhang anim nga lang sila, no? Limot ko na yung chem ko, no? So, yeah. Pero siguro, ano pa kay Prince? Fresh pa yung noble gases to him. Okay? So, thank you. So, that's another kind of set because if I will give you Einsteinium or if I will give you beryllium, hindi na siya element nung set N na dinefine ni Prince sa chat box. One more. Sige, Trisha.
Set of colors of a rainbow po. Then,
Okay.
yung opposite. I can say na yung white ay hindi po belong dun sa set.
Thank you. Kasi ang common notion natin ng colors in the rainbow ay Roy G. Biv lang, no? Tama? Pero pagka naging technical ka, sabihin mo, ang color sa isang spectrum, so magiging medyo technical. Pero I think I know what Tricia is pointing out. That would be the set containing red, orange, yellow, green, blue, indigo, and violet. Tama? So yun yung colors of the rainbow. Para maging finite set siya. Unless titingnan mo siya as a spectrum ng colors. Yeah, let's not be too technical about it, pero yun yan, okay? So basically, that's the only requirement for a set. Given an object, we can determine without the shadow of a doubt or without any doubt at all that that element either belongs or not to the set. Okay, now the membership relation, which is very important in the notion of sets in Cantorian set theory, is denoted by this epsilon-looking symbol. And we read this as X is an element of the set. So this guy is read as X is an element of A. And if X is not an element of A, then we write this statement. It's just that epsilon-looking thing has a slash on it. So, pero ginagamit na natin to dati pa, no? Pero ngayon lang natin siya define. And these two things, sets and membership to the set, are the central themes in Cantorian set theory. And makikita natin yan dun sa axioms na dineclare ni Cantor nung inimbento niya itong brand ng set theory niya nung 1870s. Okay? Yung una niyang axiom na binigay is the axiom of extension. Or sa work text, tinawag siya na intuitive principle of extension because later we will find a loophole to the Cantorian set theory. So merong isang property ng ideal axiomatic system na hindi na-satisfy yung set theory ni Cantor. It's not it's not completeness kasi dahil kay Gödel, alam na natin na walang consistent axiomatic system ang magiging complete. So we gave up with the completeness of an axiomatic system. Kaya tinanggap na lang natin na merong mga problem na hindi kayang sagutan with in any branch of mathematics, which reminds me of, I think nabanggit ko to dun sa recording, some of the Millennium Prize problems na yung iba decade-long or century-long na yung problems or yung conjectures na nandun, pero hindi pa sila na-prove. And if you will be able to prove one of those problems, I think there are 7 Millennium Prize problems, isa pa lang yata yung na-prove. Pag na-prove nyo yung isa dun sa natitirang 6, you will be $1 million richer. But of course, some mathematicians tried that already, they failed, pero malay nyo, may maisip kayong proof na hindi nila naisip. Okay? And the idea there is some people speculates that some of these decades or century-old problems cannot be solved with the branch of mathematics that we have right now. Yung mga axiomatic systems nating meron ngayon, posibleng hindi kaya nilang i-prove yung mga statements na nandun. Okay? Now, going back to Cantorian set theory, ang una niyang axiom na in-establish para sa kanyang brand ng set theory ay yung principle of extension or what he called the axiom of extension. Ang sabi niya sa axiom of extension, two sets are equal if and only if they have the same members. So ito yung isa sa tatlong foundations ng Cantorian set theory. And if two sets are equal, we use this notation, A equals B, or otherwise we write A is not equal to B. So A will not be equal to B if we can find an element of A that is not in B or an element of B that is not in A, because the principle of extension requires that two sets be equal if and only if they have the same members. So if you look at example number 5, we have the set containing 1, 3, 5. So this set consists of the first 3 positive odd integers. And then if we look at the set containing 5, 3, and 1, tapos i-check natin yung membership nila. Si 1, member ng unang set. Member din siya ng pangalawang set. Si 3, member ng unang set. Member din ng pangalawa. At ganun din si 5. And then if we also start with elements of the second set, check if they are in the first set, then we will see, or we can conclude by the principle of extension that these two sets are equal to each other. And so consequently, hindi pala nagmamatter yung paraan ng pagsusulat o paglilista ng elements ng set sa isang roster. Alright? So kahit pag jumble-jumblein mo sila, basta lahat ng nasa unang set ay nasa pangalawang set and vice versa, yung dalawang sets na yon ay equal pa rin sa isa't isa. Okay? Now, let's look at example 16. In example 16, you have the set big X. Oops. Siya yung set containing the set containing 1, 2, the set containing 2, 3, the set containing 1, 3. Ilan yung members ni capital X? Anyone? Quickly, mabilis, fast talk. Ilan yung members ni capital X? Yes, I think it's Lauren who buzzed in first. Go, Lauren. Lauren Ashley.
Sir, 3 po.
Okay, thank you. Tatlo. At sila yung set containing 1, 2. It's a single entity kasi pag nasa loob ng brackets, considered as a single object na siya. And then set containing 2, 3, and set containing 1, 3. So an efficient way to count or to see the elements of the set, pag meron kang set na naka-roster notation or naka-roster listing, burahin mo lang yung outermost set of braces, tapos bilangin mo ilan yung object separated by a comma. So imagining kung burado yung outer pair of braces, bilangin ko ilan yung nasa separate ng commas. First element is this guy, second element is that guy, third element is that guy. And these three encircled things here are regarded as single entities. So ibig sabihin si capital X, tatlo lamang yung laman. All right? Now the set Y that is defined in this example, dito naman tayo kay set Y, set containing 1, 2, and 3, obviously tatlo lang din yung laman niya. But this example tells us that the set X is not equal to the set Y. Can you guys tell me bakit hindi equal si capital X kay capital Y? Oh yes, Keith Neal.
Kasi po sir, hindi equal yung element. Since yung element po ng capital Y is 1, 2, 3 and yung element po ng capital X is yung sets po. So hindi po nag-equal yung laman ng sets.
Okay, thank you Neil. That's right, that's correct. So kasi meron kang makikita na isang element ni capital X na wala kay capital Y. Kasi ibang-iba nga yung itsura ng mga elements ng set. Sabi nga ni Keith, yung capital X ang laman niya ay mga sets. Pero yung si set Y ang laman niya ay mga numbers lamang. Pero medyo later magiging technical tayo, makikita natin na ang mga natural numbers pala ay mga sets then on themselves. Alright? Pero saka na lang yun. Pero ngayon, sets versus numbers, magkaiba sila. For instance, the set containing 1, 2 is an element of capital X, but that is nowhere to be found in the set Y. Walang set containing 1, 2 doon sa roster ni capital Y. So since we have found an element of capital X, not an element of capital Y, then it suffices to say that that is sufficient for us to conclude that X is not equal to Y. All right? And this is regardless whether they have the same number of members. Si capital X, tatlo yung laman niya. Si capital Y, tatlo rin yung laman niya. Equal yung laman nila or magkasing dami yung laman nila, pero hindi sila equal sets. Pero if you have two sets that are equal to each other, it is an immediate consequence of the axiom of extension that the two sets must have the same numbers, the same number of members. Okay? Pag equal yung dalawang sets, dapat magkasing dami yung laman nila. Pero kung magkasing dami sila ng laman, hindi magpa-follow na equal sila ng dalawa as sets. Okay? So I guess with that, you can answer exercise 7 and 8. Okay. You can just think of it on your own. Let's try. Let's dig down a little further to the intuitive principle of extension. So in principle of extension, it gives us a nice way on how to prove that two sets are equal to each other. Okay. Now, madali lang sana kung kaya nating isulat lahat ng elements ng dalawang sets, tapos mag-pairing lang tayo. Compare if one set, hanapin natin dun sa kabilang set and vice versa. Kaya lang kung infinite yung set or di natin kayang isulat lahat ng members ng set, then we must have a logical way on how to prove the equality of the two sets. And the principle of extension gives us one such avenue. The principle says it suffices to do the following. Prove that if X is in A, then X must be in B. And also, if X is in B, then X must be in capital A. And this should be done for an arbitrary element X of capital A and capital B, respectively. So parang magpo-prove tayo ng if and only if. Dalawa yung ipoprove natin. Pag nakay A siya, magpo-follow dapat na nakay B siya. At kung nakay B siya, dapat magpo-follow na nakay A siya. Alright? Now let's look at this example. All right, example 9. It says here that we need to we denote the set A to be the set of all positive even integers. So that means members of capital A will look like 2k for some positive integer k. All right? Kasi si capital A daw, ang laman niya ay lahat ng positive even integers. So sila yung mga numbers na kaya kong isulat as 2 times another integer or another positive integer. Kasi yun yung definition ng pagiging even. Alright? And then si capital B naman daw ay yung set of positive integers which can be expressed as the sum of two positive odd integers. So si B naman daw, kung meron kang laman na X na nakay B, dapat kaya ko siyang isulat as an odd integer, 2p plus 1, plus another odd integer. All right, some 2q plus 1, where p and q are positive integers. All right. So the way capital A and capital B were described, magkaiba yung description nila. Or you can think of magkaiba yung characterization ng mga elements nila. Si capital A, dapat masulat mo as 2k, where k is a positive integer. Tapos yung mga elements ni B, dapat odd positive integer plus odd positive integer. Okay, yun yung usapan dito sa dalawang sets na to. But this example challenges us to prove that A is equal to B. Of course, if you will do the brute force technique of comparing their rosters, mahihirapan ka kasi infinitely many yung laman ng dalawang sets na ito. Okay? So, yun yung magiging problema. But, thanks to the principle of extension, meron tayong paraan. Una, i-assume natin or mag-assume tayo ng isang arbitrary member X ni capital A. Then, by the way capital A was described, laman niya ay mga positive integers. So that means X should be written as 2 times M for some integer M. Now, the challenge for us, we want to show that X also belongs to B. So dapat may nag-exist na decomposition ni X, which is also 2M, as the sum of two positive odd integers, right? And the Vortex gives us one such decomposition. Sabi ni Vortex, madali lang yan. Si 2M, pwede kong isulat na 2M minus 1 plus 1. Tama? When you simplify it, you're going to get 2M back, and 2M is equal to X. By the transitive property of equality, X then will be equal to this guy. All right? Tapos, i-check natin, 2M minus 1, even minus 1, add yan. Tapos si 1, obviously, add din yan. So we have provided a way of writing X as the sum of two odd integers. So that means an arbitrary element of capital A must also be in capital B. Okay? So napakita na natin lahat ng laman ni A nasa laman ni B. And isn't it amazing na sa isang line ng proof o isang sentence, nakapag-prove tayo ng isang statement na totoo for infinitely many even integers. Alright? Napakarami ng mga positive even integers. And yet we broke no sweat in proving na lahat sila ay kaya kong isulat as odd plus odd. Alright? So, kasi kahit na marami sila, kaya ko silang i-prove with a one line. Okay? Now, we are not yet done because the axiom of extension requires also to prove the converse. Dapat pag meron tayong element ni B, mapakita na element din siya ni A. All right? So the proof will begin with an arbitrary element x of capital B. And again, by the way, capital B was described above, si B ang laman niya ay lahat ng mga sum ng even positive integers. So that means x is the sum of 2p minus 1 and 2q minus 1, where p and q are both positive integers greater than or equal to 1. May restriction na to kasi kailangan dapat maging positive odd integers yung dalawang pinagsasum natin. All right? And then if we perform the arithmetic or the algebraic manipulation here, we can add them up and then factor a common factor, we will be able to see that x is equal to 2 times p plus q minus 1. But p and q are positive integers greater than or equal to 1, then p plus q minus 1 will also be a positive integer. All right? And so x turns out to also be 2 times some positive integer, namely p plus q minus 1. And therefore, napakita natin na kapag ka sum siya ng dalawang odd, automatic siya ay even. And so that completes the proof by the axiom of extension, si A ay equal kay B. Kasi napakita natin na lahat ng members ni A ay member din ni B at lahat ng member ni B ay members din ni A. All right? Any questions? Due to lack of time, I'm gonna leave you guys with example 10. Please try this out and then let me know on Wednesday if you have some questions about this proof, okay? Or kung medyo excited kayo, i-chat nyo na lang ako or i-email nyo ako ng tanong nyo sa exercise 10. But exercise 10 would be a nice thought exercise. So try that and let me know what happens, okay? Now, gusto ko kasing maabot yung pangalawang axiom ni mangungutang ako ng konting oras. Pagbigyan nyo na ako kasi ngayon lang tayo nakita after almost half a month. So, utang ako ng konting mga minuto. All right? So the second axiom that Cantor laid down for his set theory is what we call the axiom of abstraction. Or later, it was just dubbed as the intuitive principle of abstraction. So ang sabi nito is, we can always devise a formula P of X or a statement P about objects X that can sort of characterize the members of a set A. So sa kahit anong set, the principle of abstraction tells us to assume that there will always be a formula P of X or a statement P about X that can be satisfied by the members of the set, and conversely, only members of the set can satisfy the formula P. All right? So ang gusto niya sabihin, kapag ka meron kang set, lagi kang makakahanap ng isang criterion. It could be a simple or a compound criterion that will determine the membership toward to that set, meaning those and only those members of the set can satisfy the property P. Okay? And that gives us another notation for sets. This is what we call the set builder notation. Okay? Instead of exhaustively listing down the elements of our set, ang ginagawa natin, binibigay lang natin yung defining characteristic o yung distinguishing characteristic ng elements ng set. And the principle of abstraction guarantees na pwede natin yan gawin sa kahit na anong set. All right? So, for instance, example A, this is the set of all x's such that x is an integer divisible by 3. Okay? So yung property P of x natin ay x is an integer divisible by 3. So that formula or that statement, that criterion completely determines the membership to this set. So, halimbawa si 4, masasabi natin na hindi siya member ng unang set. Kasi si 4, hindi naman siya divisible by 3. Si 6 ay member ng set kasi divisible siya by 3. Si pi, hindi siya member ng set kasi hindi siya integer. Okay? So this is an example of the property P that is guaranteed, or that is sort of that is supposed to be guaranteed by the principle of abstraction. And then you have other examples here. Set of all x's such that x is an ASEAN country. Set of all x's that's such that x is a positive integer less than 13. And set of all real numbers such that x is less than or equal to 2. All right? Now, ito yung pangalawang axiom ni Cantor. Okay? Now, may tatlong axioms na ginamit si Cantor. The third one is the axiom of choice. Pero medyo technical na yung axiom of choice. So i-discuss na lang natin siya in future topics. And you will see that the axiom of choice was later delegated to be simply a theorem. Okay? Pero kay Cantor, sa naive set theory o sa Cantorian set theory, siya yung pangatlong axiom. At may tatlong axioms lamang yung set theory ni Cantor. Principle of extension, principle of abstraction, axiom of choice. Okay? Now, for decades, nag-work naman yung Cantorian set theory. Na-develop dito yung union, intersection, cross product, at iba pa mga properties ng sets. So it looks like Cantor was able to formalize and axiomatize the development of set theory. But not over 30 years after Cantor established his set theory, may pabidang dumating, si Bertrand Russell. In 1901, Bertrand Russell, one of the greatest modern mathematicians, proved or illustrated that there's a big hole in Cantorian set theory, na yung set theory ni Cantor ay hindi consistent. There will be an internal contradiction with it. And actually, that is brought about the creation of extremely large sets that is allowed under the principle of abstraction. Okay? Sabi ni Bertrand Russell, sige, yun tatlo lang yung axiom of Cantor, axiom of choice, axiom of extension, axiom of abstraction. So, base dun sa tatlong axioms na yon, pwede kong i-define set A to be this guy. Alright? So, I can consider a set A which will be comprised of all sets X such that X doesn't contain itself. Yun yung sabi ni Russell. Sige, Cantor, tatlong axioms lang. So, pag dinefine ko si set A to be yung set na laman niya lahat ng set na hindi niya laman yung sarili nila, okay? So, possible to. Allowed to as a set under your three axioms, specifically with your axiom of abstraction, okay? Ito yung formula P of X dun sa set na to. However, sabi ni Russell, this set on itself is a contradiction. Because if you now ask, si capital A ba ay laman ni capital A? Yun yung question na pinost ni Cantor, kasi nga ni Russell. Kasi sabi natin, ang set ay well-defined collection. Binigyan kita ng isang object, kaya nating ma-determine without any doubt whether that set belongs to the set. Okay? So, question is capital A member of capital A? Alright? So, analyze natin. Kung si capital A ay element ni capital A, pero ang laman lang ni capital A ay mga excess na hindi nila laman yung sarili nila. So, imagine, so I'm testing whether A is an element of A. So, imagine replacing all excess here by A. So if we will admit A, or if we will answer in the affirmative here, ibig sabihin, dapat masatisfy ni A yung P of X. Alright, so dapat si P of A ay totoo. So, but that will tell us that A is not a member of A. Pero inassume nga natin na si A ay element ni A. So that cannot happen. Alright, so dapat pala si A ay hindi element ni A by the law of excluded middle. So kung may contradiction, kapag ka si A ay element ni A, so dapat si A ay hindi element ni capital A. Alright? However, kung si A ay hindi laman ni capital A, therefore, na-satisfy ni capital A yung property P. At na-satisfy niya yung property P na nagde-define kay A, so by the principle of abstraction, dapat si A member ng sarili niya. Pero again, that is contradictory to what we have concluded earlier that A is not in A. Okay? So, sabi ni Russell, sige, kung papangatawanan mo na ito lang yung tatlong actions mo, you have here a contradiction, this set. And that's why Cantor's set theory might have broken down. Or posible dapat na gumuho na yung set theory ni Cantor. However, Cantor's set theory is very sturdy except for this paradox or for this statement that is neither true nor false, okay? Or something contradictory to itself. Kaya ang ginawa ng mga mathematicians after Russell broached this contradiction, tinry nilang dagdagan yung axioms ni Cantor para makabuo ng set theory which will produce the same results or almost the same results or a set of parallel results to that of Cantor. Kasi napakaganda na nung set theory na naimbento ni Cantor except for this contradiction. That he overlooked niya na ito pala ay posible kahit yung axiom of abstraction ay in place. So that led mathematicians to try to extend or to add some axioms or modify the axioms of Cantor to develop a consistent set theory. Okay, so tinry nilang dagdagan yan. And we will see later, next time, kung ano yung mga dinagdag na axioms. Makita nyo, yung tatlong axioms ni Cantor, kailangan gawing 7. At yun yung tinatawag natin na Zermelo-Frankel-Skolem axioms, which is the foundation of modern set theory. But, sige na nga, sayang kasi yung meme na nilagay ko dyan. So, isang version, kung medyo magulo yung analysis ng element ni Russell, ng paradox ni Russell, ito yung isa niyang version. Isang version ng paradox ni Bertrand Russell, yung set A niya. So, sa isa daw village, or sa isang small town, sabi nung council nila, nag-iisa lang yung barbero natin sa village. So dapat itong barbero na to, ang dapat niya lang gupitan ay yung mga hindi kayang gupitan ang sarili nila. Okay? Or in a small town where every person is clean-shaven, there is only one barber. And then the council mandated that the barber will only shave those people who cannot shave themselves. Ang tanong, sino yung magugupit dun sa barber? Okay? So case number 1, may 2 cases. Either the barber shaves himself or the barber cannot shave himself. So case number 1, kung kaya ni barber gupitan yung sarili niya, so dapat hindi niya gugupitan yung sarili niya. Kasi ang ginugupitan niya lang ay yung mga hindi kayang gumupit sa sarili nila. So ibig sabihin, contradiction yon. So case 2 naman, kung hindi ginugupitan o kung hindi kayang gupitan ni barber yung sarili niya, so dapat kaya niyang gupitan yung sarili niya. Kasi kaya niyang gupitan lahat ng hindi kayang gupitan yung sarili nila. All right? And that's a contradiction. So hindi ngayon alam for sure ni barber kung kaya niya bang gupitan yung sarili niya or hindi. Okay? So that's another version of the Russell's paradox in set theory. Okay? And as I mentioned, after some time, when people learn of Russell's paradox, the barber's paradox, okay, tinry nilang i-axiomatize yung set theory. And thanks to the efforts of Ernst Zermelo, who first proposed a modification of Cantorian set theory 7 years after the discovery of Russell's paradox. Pero later, kulang pa pala yung kay Zermelo, nandiyan pa si Abraham Frankel at saka si Thoralf Skolem, who added another axiom to Zermelo's axioms. So yung tatlong axioms ni Cantor, dinagdagan ni Zermelo ng, binago ni Zermelo, tinanggal ni Zermelo yung 2, okay? Nagdagdag siya ng 5, tas kulang pa pala siya, dinagdagan ni Frankel at saka ni Skolem ng isa pa, called the axiom schema of replacement. And that set theory, which is governed by 7 axioms, is what we regard as the modern set theory, and it is now called the Zermelo-Frankel set theory. Unfortunately, it should have been called the Zermelo-Frankel-Skolem set theory Hindi ko alam kung ano yung T kung bakit hindi nasama si column sa billing. So siguro you can research on that. Bakit nawala si column dun sa billing ng set theory? Bakit ang tawag natin sa modern set theory ay Zermelo-Frankel lamang? Hindi ko rin alam, pero if you guys mahilig kayo sa mga mathematical ang tawag sa ganyan, scandals or controversies, paki-search kung bakit. So magpaka-marites kayo ng konti. Tingnan ano yung T sa pagitan ni Zermelo, ni Frankel at ni Scollem. Bakit naging et al na lamang si Scollem dun sa bagong tawag sa set theory. Okay? And if you want, you can raise your hand on our meeting on Wednesday to share with us the T between these three guys. Kung bakit nawala si Scollem dun sa billing. Okay? And we will start talking about the technicalities of set theory by first analyzing the 7 axioms of Zermelo-Frankel, and we will also see how these 7 axioms prevent the occurrence of Russell's paradox. And this will begin, or this will usher in our theoretical development of set theory. So tapos na yung TED Talk nating linggo kung saan kunento ko lang yung history behind set theory and axiomatic systems. So simulan natin yung technical discussions on Wednesday. I'll be live on Wednesday na guys. Pero siguro meron pang isa or dalawang meetings na posibleng mawala ako. Pero for next week, I'll be there to answer some of your questions. Okay? So I think that's it from me for today. Medyo lampas ako ng 2 minutes, actually 12 minutes over time. But before we end, do you guys have some questions, clarifications? So pwede nyo i-visit yung Canvas para pala ma-check yung midterm standing nyo. Hopefully your lab instructors already finished grading problem set 1.3. Sila yung assigned mag-check ng 1.3. Chinekan ko yung 1.1 saka 1.2. If you guys submitted via email due to some difficulties with Canvas and I haven't returned your papers, tapos wala pang naka-record kay Canvas, just let me know. Kasi dapat lahat ng scores yon naka-record kay Canvas. So baka na-overlook ko na checkan yung ibang mga nag-email sa akin. So just let me know. But I think I have graded all PS 1.1s and 1.2. Okay? So if there are no other questions, then those who are recited today, please drop your nicknames in the comment section. Your standing in Canvas do not include the little recitation points that you have garnered for the first half of the semester. Hindi ko pa nare-record yung recit points simula nung linggo before the reading break. I'll do that probably over the weekend so I can update your standings. But beyond that, if you don't have any questions, so it's nice to be with you again live, guys. Thank you for closing your weekend with our session today. So enjoy the rest of the night. Have a restful weekend. So let's see each other again on Wednesday. Bye, guys.
Sir, wala po sa
Okay, yeah. All right, you're welcome. Yes, Neil, nasulat na kita.
Thank you po, sir.
All right, you're welcome. Crizel, nasa Teams ka ba? Okay, si Jasmine, kinoment ka na yata ni Perlene. Na-comment na rin pala kita.
Thank you po.
Crizel, okay, thank you. Bye-bye. Okay, so nandito pala sa Teams si Crizel. Okay, thank you. Bye, guys.